Welcome back, everybody. We're going to be talking about Module 10 today. We'll be tying in some ideas that we have seen before, but not necessarily formalized. We'll also be working in StatCrunch today. When we're talking about the mean, and the mean is the balance point, since the mean is the value of the data set, balancing distances on each side, it makes sense that we would consider the distance on each side, talking about variation. So how variable is our data? When we're considering these deviations, we need to talk about what it means to be positive and what it means to be negative. And we're defining distance, or we're defining deviations as the distance from the mean. A positive deviation means you're having a value minus the mean that's positive. You have a value minus the mean, and that's greater than 0, meaning it's positive. That means that the value was larger than the mean. So this is a data point that is above the mean. And conversely, a negative deviation would be to the left of the mean, or below the mean. So this is to the right of the mean, and this is to the left of the mean. On the Learn by Doing on page 47, you were asked a couple of questions. These two questions refer to the following dot plot. The mean is 9, and it's marked by the vertical blue line. So here is the mean that they're talking about. They want to know what the deviation is from this yellow point right here. How far is that yellow point from the mean? This yellow point, it doesn't go directly above 2 or 4, but it's right in the middle, so that yellow point is 3. And the distance from 3 to 9 is going to be -6. It's to the left of the mean, which means it's below the mean. Now the deviation for the red point here is above the mean. Well, how far above the mean is it? 14 minus the mean of 9 is equal to 5. So this is one deviation, and this is a different deviation that we're talking about. It's how far away from the mean that we're concerned with. Now we're going to tie in some ideas from Module 9, where we're calculating the mean, we're going to be calculating their distances. I want you to consider the following data set, 2, 3, 4, and 7. I want you to find the mean of the data set. Remember, that means I'm going to sum all of the x values and divide that by n. 2 plus 3 plus 4 plus 7 is 16. And 16 divided by 4 is 4. So the mean of this is 4. And remember that mean means average. Now I want to find the deviation of each value. If I had these numbers on a number line, I'm going to mark my mean here. And then I want to know how far away each value is. Well, for 2 minus 4 is -2. So 2 is 2 below the mean. 3 minus 4 is -1. 3 is 1 below the mean. 4 minus 4 is 0. 4 is exactly at the mean. And then 7 minus 4 is 3, which is 3 above the mean. Remember that you're always putting the value before the mean. Okay? You definitely want to make sure that you're putting the value first. As a first step in finding the average, we would add them up. What is the sum of the 4 deviations? Well, what they're saying is if we were trying to find the average of -2, -1, 0, and 3. Okay. -2 plus -1 plus 0 plus 3 divided by 4. -2 plus -1 is -3. And -3 plus 0 is -3. And -3 plus 3 is 0. So the average is going to be 0 divided by 4, which is 0. Will this always be the case, or did this just happen? This should always be the case. Can you think about why? Remember that the mean is a balancing point, and you're balancing the values of the data and the distribution to the left and the right. So your deviations on the left should be equal to the deviations on the right. Otherwise, we haven't calculated our mean appropriately. There are times when you are using decimals and you've rounded, and you might get 0.01 or negative 0.01 instead of actually 0, and that's just due to rounding error. To take care of this problem of always getting 0 when we're adding the deviations, we could handle that negative by taking the absolute value. Remember that the absolute value of something is the distance of a number from 0. We covered that earlier in this semester. So distance is equal to the absolute value of the deviation. Using the values from before, 2, remember that the mean was 4. We're carrying this over from the other page. 2 minus 4 was negative 2. 3 minus 4 was negative 1. 4 minus 4 was 0. And 7 minus 4 was 3. Now taking the absolute values of each of those values, it just makes all of the numbers positive. Now I can find the average without worrying about things canceling out. Remember, my average is the sum of all the values divided by n. That means I have 2 plus 1 plus 0 plus 3 divided by 4. The numerator is 6 divided by 4 gives me 1.5. Now that gives me a little bit of a value. Looking back at my number line here, is that on average, the distance from this mean here is about 1.5. Okay? The one on the right-hand side is further out. The one on the left-hand sides are closer together. What are the 3 ways to measure variability that we've discussed so far? We talked about in Module 9, we talked about range and IQR, and then we just talked about something new in Module 10. The interquartile range, the range itself, and the absolute deviation from the mean, which we are abbreviating ADM. We're going to move to StatCrunch, where we're going to enter the values here, and we're going to perform the calculations that are on this sheet.